Let's build a machine learning model to predict the outcome of a very special game happening tomorrow. We're in the 17th week of the NFL Championship, and tomorrow there's a game between the Philadelphia Eagles and the Buffalo Bills, and everyone has their own take of who's going to win. But instead of arguing about feelings, we're building a supervised machine learning classifier on this real-world Kaggle dataset to predict the outcome of the game. More specifically, we're building an extreme gradient boost classifier. Essentially, this is a model that builds lots of small decision trees sequentially, so each tree is meant to correct the mistakes of the current model. And the final output is the combined vote of the ensemble of trees expressed as a probability of the home team winning. And with that, let's get coding. We always start by importing the necessary libraries. Today we have NumPy for math, Pandas for data, XGBoost to run the classifier, and some tools from scikit-learn to help us deal with the data and evaluate the model. Next, it's time to load in our data and set some variables. We're using Pandas to read in the CSV from Kaggle, and we actually have two different paths here containing two different data tables. The scores file contains the actual game rows with the date, the home team, away team, etc. While the team's path is a lookup table that translates full team names into consistent team IDs that are easier to track. Then we're making a creative choice about the world our model will live in and choosing to focus on the modern era of football. Rules and styles have changed a lot over the decades, so games from the 60s would only confuse things. And that's why we're starting the dataset at the 2002 season. Finally, we're defining the date, home team, and away team for tomorrow's game, so the model has that information easily accessible in a variable. Here we're writing a function called loadData, which turns raw CSV files into a clean game table the model can learn from. We parse dates and seasons so we can sort games in time order, filter out seasons before 2002, and remove all of the playoff games. Then we map the team names to those IDs and create the target variable yHomeWin, which is what the model is trying to predict. Next, we're defining a function called addElo pregame. Essentially, we're creating a team strength signal that evolves over time and can be used before each game kickoff. So the code records the home and away Elo ratings as they exist pregame and then updates only after the result is known. Next, we're building a team-by-team history table so we can tell each team's form going into the game. Before kickoff, it's important to know how much momentum a team actually has that season. Are they hot or icy cold? So we convert each previously played game into two rows, one from the home team's perspective and one from the away team's perspective. Then we're creating a lot of pre-game rolling summaries that only use games that happened before the current game. And this is doing the important job of excluding the current game so we don't accidentally use the game's own result to predict itself. Season to date captures what the team has looked like this season so far, and last five captures what the team has looked like more recently. And this is very helpful when a team is trending up or down. Now we're finally building the actual feature matrix that XGBoost will learn from with one row per played game. We're feeding it the difference between the home team and the away team because that's what the game really is. Who has the edge? So we're giving it things like the Elo gap, gap in recent form, gap in rest days, plus simple context. Now we are finally training the XGBoost model on all the games that happened up to tomorrow's game. And this is where we're performing our time-based train test split. Instead of randomly shuffling the data, we split it by time. That means we train on older games first and then we test on more recent games. Because that's the only setup that actually matches real life. You're always trying to predict the future using the past. Then we print tons of evaluation metrics like the logistic loss, Breyer score, accuracy, and ROC AUC. And here are the evaluation metrics for this model. This is where it gets interesting because we're building right up to the game kickoff. Essentially, we're summarizing how each team has been playing up to kickoff. We're looking at all the games that have happened so far and then estimating the rest by looking at the team's most recent game and how many days have passed until this one. We're almost done, and here we're building a single feature row for the Bills versus Eagles game and asking the trained model for a Bills win probability. We locate the scheduled row to pull out the week and season and compute both teams' pre-game form. We force the columns into the exact same order used during training, so the model reads the correct numbers, and the return probability is the chance the Buffalo Bills will win. Now finally, we are running the full pipeline, and the order has to happen. We load the data, create the Elo, create the rolling team form, assemble the training set, train on past games, and then generate the probability for tomorrow's specific matchup. And for the final result, drumroll please, the model predicts that the Buffalo Bills will win with a 63% certainty. And with that, don't forget to save this video so you can come back to it after the game on Sunday. Let me know who you're rooting for in the comments and follow for more. See you in the next one.